Welcome to lesson 5.1 and welcome to chapter 5. We're going to be doing radical functions and rational exponents in this chapter. So the first question is, what are all real cube roots of 125? So an nth root of a number c is x, such that x raised to that power of n is equal to c. An nth root can be denoted by a radical symbol with an index. The index is the n, the c is the radicand. So if you're going to represent the real cube root of 125, you would write it as x is equal to cube root of 125, like that. Find the values of x such that x cubed is equal to 125. To solve that, x cubed equals 125. Note that 5 cubed is equal to 125, so 5 is a root. Consider if there are others. Recall that the complex solutions to polynomial equations come in pairs. The number of real roots depends on the degree of the equation. So an odd degree will have an odd number of real roots, and an even degree will have an even number of real roots. So if you set it up like this, x cubed minus 125 equals 0, and you factor the difference of cubes using that formula, you get that x minus 5 equals 0, gives you that root of 5 that we already knew about. And x squared plus 5x plus 25 is a quadratic that has a negative discriminant. So those roots are not real. Therefore, 5 is the only real root, real cube root of 125. So how about fourth roots? Specifically, this one's fourth root of 16. So we would write it x is equal to fourth root of 16. If you set the expression equal to 0 and you factor, you end up with x to the fourth minus 16 equals 0. It is a difference of squares, and you get x squared minus 4 times x squared plus 4. X squared minus 4 can factor again, because that is still a difference of squares, and you get x plus 2 times x minus 2 times x squared plus 4 is equal to 0. From the x plus 2, you get negative 2, and from x minus 2, you get 2. X squared plus 4, if you solve by taking the square root, you subtract 4, and you take a square root of a negative, and it's imaginary. So the real roots are 2 and negative 2. If you just wrote it as the fourth root of 16, that would only represent the principal root. So it would only represent the positive one. But if you wrote it as an equation and solved it, 2 and negative 2 are both solutions. So at this point, why don't you pause, give these two a try, and then come back and check your answers. So with the first part here, part A, factored, and I got x is equal to plus or minus 3. The other two roots would be imaginary. They'd be plus or minus I root 3 if you actually solved them. And then for part B, factored and got x is equal to 4. The other two roots would be imaginary if you did quadratic formula with x squared plus 4x plus 16. All right, so why don't we try example 2.